Okay, we were almost finished number 7. We were doing the last part, part D, which was the orbital velocity. We had rearranged AC equals V squared over R. We were multiplying our 3.226 by our R, 3.63 times 10 to the 6th. You were about to take the square root, and if you did, you would get 3,421.98 meters per second. Number 7 is done. Number 8 says a satellite with a mass, oh look at that, this time I was nice, 640 kilograms is in orbit above the Earth's surface where the gravitational field strength, that's little g, is 8.6 meters per second squared. What is the gravitational force? So we're looking for Fg, and I give you m and little g. I think I would probably just do m times g. So 640 kilograms times 8.6 meters per second squared. And when you do this, you should get an Fg of 5,504 newtons. Sorry. Okay. Part B says, I think I did that one right. I'm looking for my right answer sheet here. Oh, there it is. Part B says, what is its altitude? So what is its height? To find its height, you need to find its radius. I'm looking for my formula sheet. So we have Fg. We know it's above the Earth. We have R. We could use this one. We actually could use this one, which would be easier because we have little g, we have the mass of the central body, so we could find our capital R from that, okay? So I would use little g is equal to g, mass of the Earth, because it says above the Earth, over R, and R squared. And now we're solving for R. So R squared will be equal to g, mass of the Earth, over little g. So R squared will be equal to 6.673 to the negative 11 Newton meters squared per kilogram squared. Mass of the Earth, if you don't know it by now, you can always look it up on that chart. It's 5.98 times 10 to the 24th. And little g, they gave us in the question, 8.6 meters per second squared. Remember, that's going to be R squared. You then need to take the square root, okay? And when you do take the square root, you should get 6.81 times 10 to the 6th meters. But that's not what the question asked. The question asked for the height. So the height is going to be this R of the satellite minus the R of the Earth. So 6.81 times 10 to the 6 meters. And the R of the Earth you can also get off this handy dandy chart if you don't have it memorized from using it so many times. It is 6.38 times 10 to the 6th meters. Okay, so when you subtract these, you're going to get 4.318 times 10 to the 5th meters. That is part B. And then part C wants to know its orbital velocity. Well, now that you have its R and you have little g, and remember little g and AC are the same. So in part C, I would use AC is equal to V squared over R. And so V squared is equal to AC times R. So V squared is equal to the 8.6 they gave us in the givens, and the R that we just found, not the H, the R. Okay, so 6.81 times 10 to the 6 meters. And remember, that's going to be V squared. You're going to need to take the square root. And you should get 7,658.85 meters per second once you've taken the square root. Before the square root, it's something like 5.857 to the 7th meters squared per second squared. Okay, so that's number 7. Number 8. A 1,000 kilogram satellite is put into circular orbit above the Earth. Okay, so mass is 1,000 kilograms, and it's above the Earth, so that means the mass of we know the mass of the Earth is 5.98 times 10 to the 24th as well. So that it remains over the same place on the Earth. So it's a geosynchronous one, like we talked about in one of the earlier videos. So its period is 24 hours. And if you switch 24 hours to seconds, you should get 86,400 seconds. All right, so it's a geosynchronous satellite. What is its radius of orbit? So if we have the period and we have the mass of the central body, I would use r cubed over t squared is equal to g mass of the Earth over 4 pi squared. Newton's version of Kepler's third law. Take your t squared up. So r cubed is equal to g mass of the Earth t squared over 4 pi squared. So r cubed is equal to 6.673 to the negative 11 Newton meters squared per kilogram squared. Mass of the Earth 5.98 to the 24th kilograms. The period 86,400 seconds squared over 4 pi squared. And remember, put that in brackets on the bottom. What you're going to get out is going to be r cubed. It's 7.47 to the 22nd meters cubed, and then take the cube root. 4.212 times 10 to the 7th meters. Okay, so that's its radius. And when I look at the question, what is the radius of this orbit? So that's all it's asking for. It's not asking for the height. Actually, I looked at the wrong. It's really, shoot. I did it 2 different ways. This is if you do it a different way. Ignore those 2. If you do it with the numbers I have here, I did, this is if you do it with the moon going around the Earth, like the r cubed over t squared equals r cubed over t squared. If you do it this way, it's 7.5455 times 10 to the 22 meters cubed. And then take the cube root and you get 4.2257 times 10 to the 7th. And the difference here would be just because of rounding, right? Rounding the mass of the Earth, rounding for the numbers for the moon. Sorry about that. I did it both ways and then I forgot to. What would it weigh in orbit? So FG is equal to GMM over R squared. So 6.673 to the negative 11 Newton meters squared per kilogram squared. Mass of the Earth 5.98 to the 24th. Mass of the satellite was 1,000 kilograms. And the R, I'll use the one that I should have written down first up there, 2275 to the 7th meters squared. And you get an FG when you do this of 223.475 newtons. Okay, that's the one I think that matches your sheet. And then C wants to know how fast is it going. So it's looking for V. So you could either do V squared is equal to G mass of the Earth over R. You could do FC equals mv squared over R. 6.673 times 10 to the negative 11 Newton meters squared per kilogram squared. 5.98 to the 24th. And 4.2257 to the 7th. Don't forget to take the square root, and you should get 3073. You could have also done V is equal to 2 pi r over t, because you have both the r and the t. They'll all end up very close to this. A little bit different, just because of the rounding of masses or radii, okay, but within the same ballpark. And if I was giving you a test on this, I would have, like I did up here, like the different possible answers you could have gotten depending on which way you did it. Okay, so that's it for number 8. And that's the end, except for your practice assignment of universal gravitation.